good day to everyone. Okay, welcome to my channel. Okay, next problem solving related to simple harmonic motion, which is the spring. Okay, for this kind of problem, for example, given a spring with a spring constant, so we know the spring constant is K, the symbol is K. The spring is hanging vertically as shown in this figure. So a 20 Newton weight is attached at the end of the spring, and the spring is stretched by 10 cm. So this weight of this block is 20 Newton and it's stretched by 10 cm. So when t equals to 0 second, which is at rest, the spring is then stretched by additional 5 cm. So the spring is pulled down and the spring stretched by additional 5 cm and release. So okay, question asks to calculate the spring constant K, the maximum displacement, the time taken to complete one oscillation, and the frequency and angular frequency. So frequency is F, angular frequency is omega. Okay, so to solve this kind of problem, so for A, spring constant K equals to what value? Okay, first we need to recall back the formula Hooke's law. Given Hooke's law is a F equals to negative Kx. Okay, F related, which is the force, but in this case F is the downward force here, which is the mg. Okay, so mg, okay, to substitute the value into the formulas, we just can ignore the negative sign. Okay, so mg equals to kx. X is the value for the stretch value, which is in this case is 10 cm. So mg, or the weight is a 20 Newton. Okay, K we need to find K, and X is a 0.1. So the value K is a 200 Newton meter minus 1. Okay, the spring constant. Okay, next question asks to find the maximum displacement. Okay, maximum displacement for spring or for pendulum, when a complete oscillation, the maximum displacement we need to know, which is the amplitude A. So in this case, when t equals to 0, so when t equals to 0, so the spring is stretched by another 5 cm. So this is the maximum displacement, which is the amplitude equals to 5 cm. So the answer for B is a 5 cm, the maximum displacement or the amplitude. Okay, next, the time taken to complete one oscillation. Okay, the time taken to complete one oscillation. Okay, the formula, we have the formula period T equals to 2 pi square root m over K. Okay, M is mass, K is a spring constant. Okay, given the weight is 20 Newton, so we need to change weight to mass. We have the relationship, which is weight equals to F equals to mg. So for here, to get the mass, okay, so substitute first. Okay, 2 pi square root, okay, mass here is 20 Newton. Okay, we need to find mass, and g is the acceleration of gravity, so 9.81. So mass is a 20 Newton divided by 9.81. So here 20 divided by 9.81 and divided by K, 200. Okay, solve this equation. So you will get the answer is 0.63 second. Okay. Next, the frequency and the angular frequency. So since we have the formula for period or the time, so we can find the frequency by substitute into the formula. F frequency equals to 1 over T. Okay, so 1 over T, substitute 1 over T, T is 0.63, so the frequency is 1.59 Hertz. Okay, 1.59 Hertz. Then question us to find the angular frequency, which is the omega. So omega, we have the formula. Omega equals to 2 pi f. So from here we have frequency 1.59. Just substitute into this formula, 2 pi 1.59. So the omega or the angular frequency is 9.99 radian per second. Okay, that's all. So the K value, the amplitude, the time taken to complete one oscillation, which is the time or the period, the frequency and the angular frequency. Okay, that's all. You can try by your own self. Okay, good luck.